All right, ladies and gentlemen, this is going to be section 5.2 lecture in our population chapter, and it will be the last lecture of our chapter before our test. We're going to look at some things that can control population growth and what kind of keeps our population numbers in check. So first off, we're going to look at things that are called limiting factors. And a limiting factor is anything that's going to control the size of a population. So anything that can cause a population from kind of growing too much and can go ahead and kind of limit the size and mainly keep it around that carrying capacity that we talked about last section. Now, changes in a limiting factor, if there's something that changes in one of these factors, it could cause either a long-term or a short-term change in that population size. So realistically, if there is a change in the limiting factor, it could overall possibly change what the carrying capacity of that population is. Now, the good thing is that limiting factors actually keep most of our populations from growing out of control. So we know based on last section that populations can't continue growing exponentially. Eventually, they're going to go ahead and start to slow down based on resources. So a lot of those limiting factors, those things are going to kind of limit just how big that population can get. And when we look at limiting factors, there's going to be two overall types. There's going to be what's called density dependent, and there's going to be what's called density independent. So we're going to go ahead and look at both and look at some different examples and what they are in the following slides. So first off, a density-dependent limiting factor is going to be one that affects the population most when individuals live really close together. So whenever you think of the word dependent, that just means it relies on something. So if it's density-dependent, it's a factor that relies on the density or the idea of kind of how crowded that population is. Okay, the more crowded the population is, the more closer the individuals are living together, the more effect that these factors are going to have. Okay, now the most that get affected in this are going to be very large populations, mainly because they're going to be very dense. They're going to be very, very crowded, living really close together. So these limiting factors are going to really affect their population. Now, the first type of density-dependent limiting factor we're going to look at is competition and overcrowding. So when you think of an area being crowded, organisms are going to start competing for things. So if there's too many individuals, there's not going to be enough resources like food, water, space, sunlight, mates. So they're going to start competing for those things. So only really one is going to be able to win the competition, and the other is typically going to lose, and realistically in nature, that means they're going to die. So when we start competing for those major resources like food, water, and space, because the density is high, because it's overcrowded, we start to see a lot of competition for those resources, and in the end, a lot of times we'll see some death for those organisms that don't quite win. Now, another density-dependent factor is parasites. Parasites and disease will cause a population to decrease. Okay, a parasite is anything that can go ahead and kind of take on another organism and kind of suck all of the nutrients out of it. So this is an example of a caterpillar that has been infested by a parasitic wasp. And what that parasitic wasp does is it lays all of its eggs. Those are what those little white things are on the caterpillar. It lays its eggs on there, and the eggs, while they're developing into adults, they start sucking all of the nutrients out of that caterpillar. And then they go ahead and they end up hurting the caterpillar by pretty much taking all of its nutrients and causing it to die. So the more dense a population is, the more crowded that population is, the quicker parasites typically go ahead and start kind of moving along into different organisms and can go ahead and cause more disease and more issues and cause more death. So whenever parasites or any type of disease is starting to spread, definitely spreads quicker when there's a lot closer contact. So think about in the flu time, in the fall when we have flu starting up, more of it is passed along because we're all in school and we have a lot closer contact with a lot more people. It's a lot more dense here at school than if we were in the summertime at home and we're not having as much contact with people as we do in the school season. So that's why we see like flu and things start to really move around the school much quicker because it's a dense population. It's more crowded, and people are able to have that spread around much quicker. Germs move a lot quicker with that close contact. Now, another one, density dependent, is herbivores. More herbivores cause the plant population to decrease. So think about what we've talked about with our types of consumers and our food chains. So if we have an overcrowding, okay, or a very, very dense population of herbivores, that's going to affect our plant population by causing it to decrease because those herbivores are going to be eating a lot more of those plants. Now, if our herbivores are less dense, there's a fewer group of herbivores, that's going to allow our plant population to increase. Okay, so we're looking at kind of those interactions that our populations can have with each other. So if herbivores are dense, it's going to cause our plant population to decrease. Okay, the density depends on how that's going to limit one's population. So more herbivores, more dense, going to cause our plants to decrease because there's going to be a lot more herbivores eating those plants. Now, another density dependent factor is predators. Okay, predator and prey relationships. We looked a little bit about this already, but realistically what we're saying is that the more predators there are, that's going to cause our prey population to decrease. And then on the other hand, if there's fewer predators, that's going to cause our prey population to increase. So kind of looking at how the density of one population can affect the density of another. If predators are high, that means prey is going to be able to go down because the density of the predator is high. It's going to cause the density of the prey to decrease because there's too many predators hunting. If the predator population is low, if it's a less dense population of predators, that's going to allow our prey to increase. We're really looking at that relationship, how they can affect each other's population numbers. All right, now looking at our second category of limiting factors, density independent limiting factors. So whenever we think of the word independent, okay, it is no longer dependent. It doesn't rely anymore on the density of the population. It is independent of the density. So it doesn't matter how dense or how crowded that population is. It's going to affect all of the populations in the exact same way, regardless what their size is. It doesn't matter if the population is very sparse. It doesn't matter if the population is extremely overcrowded. Either way, whatever this factor may be, it's going to affect the population the same. Now, some ideas of what some density independent factors are things like bad weather, natural disasters. Okay, you have a tornado or a hurricane come in, one of these big natural disasters, it's going to wipe out the population regardless of the size. It's not going to matter if it's a really large population, really small population. Either way, a natural disaster is going to come through and it's going to end up pretty much wiping out the whole population. Okay, same thing with wildfires. We hear a lot about wildfires coming through on the West Coast, areas like California. And it's not going to matter what those populations of organisms are, whether there's a lot or a little of them. If a wildfire comes into that forest, it's really going to go ahead and deplete those populations a lot. Again, not dependent on how dense it is. Either way, it's going to wipe them out. Okay, things like human activities are density independent. So us going in and clearing a forest out completely to go ahead and be able to build different, malls and homes and things, that's going to wipe out the population that lived in that forest either way. Again, it's not going to matter. It's not going to be dependent on just how dense that population was. Doesn't matter if there's 5 or 10 of those organisms, they're all going to be wiped out if we take out their habitat. Okay, so just some different things for density independent. Okay, it's more weather related, more major natural type disasters. And again, it's independent of the density. It doesn't matter how crowded or how not crowded that population is. It's still going to go ahead and affect it the same way. And usually it deals with kind of wiping out that population altogether. All right, that's it for this lecture. It's a nice short one. If you have any questions, make sure to ask questions in class, and then we should be good for the chapter.